So next up, this is 5.1. It's kind of in between 5.1 and 5.3. I'm not quite sure where this should be applied, but we're putting it in 5.1. So we want to see some relations between trig and its inverse. We learned before that, let's say, sine of inverse sine of 4 over 5 is equal to theta, because the inverse gives me theta. This is equivalent to sine of theta is equal to 4 over 5. What does sine tell us? What is the ratio that sine uses? Sine uses opposite over adjacent. That is my ratio for sine. So this must tell me opposite over, not adjacent, opposite of hypotenuse. I misspoke. Since sine theta is 4/5, and that ratio gives me opposite of hypotenuse, if we ask you to make a triangle that makes this true, we could just plot down a little triangle. It doesn't have to be to scale, just draw a regular right triangle. And with theta over here, opposite of theta is 4, the hypotenuse must be 5. This is a triangle that relates to sine. However, one thing to keep in mind, which we didn't talk too much about in class, so we'll talk about it more in a review day, is that we see that sine, we also need to keep track of our quadrants, because we see it is positive, so it is quadrant 1 and quadrant 2. Keep this in mind. We'll store it here. We'll look back on it in a bit. One application of this is if we apply it in a layered way. So for example, I want to find cosine of inverse sine of 4/5. There's a lot going out here, but we just work inside out. And the way we do it is that when you have an inverse sine inside, we want to find our angles. What angles apply to this? And what we can do is we make our angle by making the triangle, getting 4/5, making this triangle right here. And now we want to find cosine of these possible angles. So cosine of theta is what? It is adjacent over hypotenuse. Cosine of theta is adjacent over hypotenuse. So we must find adjacent. How do we find this value right here? One way of finding it is use Pythagorean theorem, where a squared plus b squared equals c squared. If this is true, we must have it where a squared plus 4 squared equals 5 squared. Or a squared plus 16 equals 25. A squared equals positive and negative, or like a squared equals 9. So a equals positive and negative 3. You might be asking like, oh, we can have a positive for a triangle, but how can we have negative for this triangle? We can't have a negative because of the quadrants. So in quadrant 1, cosine would give me a positive value, because cosine is positive in quadrant 1. However, in quadrant 2, cosine is also negative. So cosine of theta is equal to adjacent over hypotenuse, and we have two possible triangles. We have 3, and we also have negative 3. So to fully solve this out, we want to write it down. Cosine of theta could either be positive 3 over 5 or negative 3 over 5. And these are two possible answers. Another way to solve this is you actually solve it out fully and find out, oh, like what theta values do I have? And when you solve it out, you will do just like what I said before. you would get a value that's in quadrant 1. You'll get a theta value that's also in quadrant 2. And when you plug those two angles to cosine, you'll get one that is positive and you'll get one that is negative. So instead of doing all that work out, we cut the work out by just looking at this triangle and understanding that when I have quadrant 1 and quadrant 2, one will be positive and one will be negative for cosine. Keep in mind that if we do have, let's say, sine out here, they will both be positive. So let's summarize this idea in one little, in one walkthrough. So when I have a problem like this, a problem with cosine, a trig function out here, and an inverse inside. With the inverse inside, we do that first, always inside first. And with the inside, we make our triangle. If it's an inverse, we make our triangle. Because inverse tells me two sides, and I don't know the angle. Once the inverse makes me my triangle, we now apply the outside trig function. Actually, before we do that, we first notify what quadrants we are in. So it being signed to give us this triangle tells me that I have quadrant 1 and quadrant 2 as my quadrants for this triangle. Now we look at our isosceles trig function, and we want to solve for this, solve for the ratio of it, by also keeping in mind our quadrants. So I solve for the ratio of cosine by kneading the third side because it's adjacent over hypotenuse. I find out that adjacent is 3, so I have 3/5. But quadrant 1 is positive 3/5, and in quadrant 2 it must be negative 3/5. Okay, so altogether we have this all typed out. If you have an inverse trig on the inside, you make your triangle with the inside function. You label your quadrants. You solve for your outside trig function. You may need to find your missing side. And then you want to give all possible answers by checking your quadrants. So the plus minus here did work out for us, but you just leave it as plus and then use that to then find. So you could either look at it here or look at here, which I think is easier. So you solve for the outside trig function and you give all possible answers by checking the quadrants. Because cosine and sine have not fully overlapping positive and negatives. Let's do one more. And this one might be a bit unclean. So say secant of inverse tan. Let's use the triangle 8 and 12. I think this is a clean triangle. Hopefully it is. If not, we'll do some math and do some square roots. So with this triangle, we first make a triangle. The size doesn't matter. Tangent is opposite over adjacent. 8 over 12. Our quadrants for this are quadrants 1 and quadrants 3. We now want to find secant. Secant is actually 1 over cosine. If it's 1 over cosine, that must mean it is, if cosine is adjacent over hypotenuse, cosine must be hypotenuse over adjacent. So I want to find hypotenuse over adjacent. I don't know hypotenuse. We use Pythagorean theorem. A squared plus b squared equals c squared. 12 squared plus 8 squared equals c squared. 144 plus 64. It doesn't work out cleanly, I don't think. Ooh. Calculator. 144 plus 64 gives me 208. The square root of 208 is 14.42. 208 equals c squared. C equals 14.02. 42. So I found my last side, 14. Now when I've solved for the outside trig function, so secant of theta must be 14.42 over 12. I look at the quadrants, give all possible answers. Secant and tangent does not fully overlap. So therefore, quadrant 1, secant or cosine is positive, and quadrant 3, cosine is negative. So my answers are 14.42 over 12, as well as negative 14.42 over 12. We can give these out in decimal, but since it is a ratio, I will accept these fractions.